In this video, we're going to talk about the benefits of a hierarchical design when planning a network. Usually networks grow kind of organically. We start out with a small device and a few workstations. Think about your home network. You have a couple of computers and you have some other devices, perhaps a printer, and perhaps maybe a game console. And all of these things plug in or connect wirelessly to your home network. But imagine that if you began a home-based business, all right? Your network would then need to grow. You might need some additional devices, some additional workstations. You might need some additional things like scanners and printers. So I might have a scanner out here and maybe another printer. And then all of a sudden I realized that my small little home networking device no longer has enough ports to support all of my various devices. As my small business grows and we remodel the garage to put it in, now I have to have another device. And usually we attach that device to the other device, and then the network begins to grow organically. This is true of your home network, but it's also true of enterprise networks. Many times businesses of all different sizes don't think about how they're creating their network. They just allow it to grow as they need more devices on the network. But pretty soon, we end up with a network that has mission-critical devices, say for example a server that your customers needed to get to, attached with things that really don't need to see that types of traffic or might actually even interfere with it in the case of the game console or someone downloading a movie. So basically a network that just grows organically is sometimes not all that efficient. So what we see is over time a different type of network architecture has become pretty much the standard. And that is called a hierarchical network design. In a hierarchical design, we think about how are we going to organize our network such that we have important things like servers separated from the user groups that might be, again, those people downloading Netflix or playing a video game. And we want them separated from the users that have to be critically important. Now, you also will see in enterprises and small businesses, this process is repeated multiple times. And hierarchical networks are able to scale because they are logically designed in a manner such that traffic that needs to go from these people to these servers does not need to travel over to the areas of the network where it's not necessary. Now, we had a little discussion earlier about broadcasting. Broadcast packets go to everyone that is in the same local network, meaning the same area of the network that is only connected by a switch. So in this instance, all of the broadcast traffic that is generated by the various devices, and even though I've only drawn a couple, in some cases this could be hundreds of devices. So all of the traffic that's generated by these devices will remain in this area of the network. So hierarchical networks scale quite well. Now, when the hierarchical network needs to connect to other networks, we will have other devices that provide the connectivity to get out to, say, the internet. In a hierarchical network design, there are names given to these various layers. Devices that actually connect users and other end-user devices reside at the access layer. The primary function of the access layer of the network is to provide an entrance point for devices to get on the network. Some types of things that are at the access layer are end user computers, but you'll also see IP phones and access points that provide wireless entry. And at some degree, you will see servers and services being provided at the access layer. The next layer up is the distribution layer. The distribution layer's main function is to interconnect the access layer networks and to direct the traffic such that traffic that needs to stay local stays local, and traffic that needs to traverse to remote networks actually has a path to use to get from one network to the other. Now, above all of that is the core layer. The core layer is responsible for the high-speed processing. So in this case, we have all of our users that need to get to the internet. So our core layer is going to take care of aggregating all of the traffic that's coming from these various devices and making sure that it efficiently is transmitted across the WAN links to the internet. So basically, this is one of the main reasons why we need to think about the planning part of our networks before we're building them. It's not really critically important when you're building a home network, but once you start into a network that needs to be up and operational most of the time, you really have to think about having a design that a failure of this component does not impact all the rest of the network.